Example 3. Accuracy of a linear approximation. For what values of x is the linear approximation, the square root of x plus 3, approximately 7 over 4, plus x over 4, accurate to within 0.5? And what about accuracy to within 0.1? So accuracy to within 0.5 means that the function should differ by less than 0.5. So what that means is we want to find, okay, the absolute value of the square root of x plus 3. Okay, and if we subtracted the 7 over 4 plus x over 4 to the left side, then that is minus 7 over 4 plus x over 4. And we want to find out when that is the absolute value is going to be less than 0.5. Okay, so then we can rewrite this as the following. This is going to be, we have negative 0.5 with the absolute value inequality, and that's going to be less than the square root of x plus 3. Distributing the sign, is minus 7/4 minus x over 4, and that's less than positive 0.5. Okay, so now what we want to do is we then want to then solve. So we want to then 7/4 is the same thing as 1.75, but we're going to add 1.75 to all three sides. So by doing that, we get 1.25, which is less than the square root of x plus 3 minus x over 4, which is less than 2.25. Okay, so now we want to get rid of that 4. So we're going to multiply each term by the value of 4. So if we multiply every term in here by 4, 4 times 1.25 is going to give us 5. And this is going to be 4 times the square root of x plus 3. And then minus 4 times x over 4 is going to give us minus x. And then 4 times 2.25 is going to give us 9. Okay, and now what we're going to do is we want to add x to all three sides. So we're going to add x to all three sides. So therefore we get x plus 5, which is less than 4 times the square root of x plus 3, which is less than x plus 9. Okay, so now what we want to do is we want to square all three sides to get rid of that radical. So the next step is to square all three terms. So therefore, we have x squared plus 10x plus 25, which is less than, well, this is going to, 4 squared is 16, gets rid of the radical, so that's x plus 3. And then this is x squared plus 18x plus 81. So now let's go ahead and distribute that 16. So we have x squared plus 10x plus 25, which is less than 16x plus 48, which is less than x squared plus 18x plus 81. Okay, so what does this tell us? Well, we can now break this up into two inequalities. Okay, we have x squared plus 10x plus 25, which is less than 16x plus 48. And over here we have 16x plus 48, which is less than x squared plus 18x plus 81. Okay, so on the left, we're going to get x squared. If we subtract 16x from the 10x, we're going to get minus 6x. And if we subtract the 48 from the 25, we're going to get minus 23. And therefore, that's going to be less than 0. Okay, on this side, if we subtract the 16x and the 48, we're going to get 0 here, and that's going to be less than x squared plus 2x plus 33. So what do we know about x squared plus 2x plus 33? Well, let's go ahead and graph that real quick. Okay, so we have x here squared plus 2x plus 33. Okay, so where is that located? Well, that's above the x-axis. So let me go ahead and copy that here. So since it is above the x-axis, what can we say about that? Well, we can say that, okay, is this function always going to be greater than 0? Well, yeah, because it's above the x-axis. So therefore, this is always true. Okay, so now what we want to do is we want to be able to solve this inequality here. Okay, so this is telling us that x squared minus 6x minus 23 is less than 0. And so what that means is once we solve this, and we're going to use the quadratic formula, those values are going to be within that interval for x. So we're going to solve by using the quadratic formula. So we have x, which is equal to negative 6, or negative times negative 6. And that's plus or minus b squared minus 4ac. So we have negative 6 squared minus 4 times 1 times negative 23. Move that over here. And then we're going to divide that by 2 times a, which is 1. And so therefore we get x, which is equal to 6 plus or minus the square root of 36 plus 92 all over 2. So x is going to equal 6 plus or minus the square root of 128 over 2. And if we simplify the square root of 128, we get 6 plus or minus 2 times the square root of 32 over 2. Rewrite that. So 32 over 2. And so if we simplify that, we end up getting 2 goes into 6 3 times. Plus or minus 2 goes into 2 1. So that's 3 plus or minus the square root of 32. And so therefore x is going to equal 3 plus or minus 4 times the square root of 2. So what that tells us is that for this one here, we know that we have 3 minus 4 times the square root of 2. And over here on the right side, it's 3 plus 4 times the square root of 2. So what that tells us is that the approximation is going to be accurate to within 0.5 for x is going to be in between negative 2.7 and positive 8.6. Excuse me, 8.7. So now what we want to do is we want to then be able to find what about the accuracy within 0.1. So let's go ahead and work on that. Okay, so just like we did in the previous step there, we know that we want to look at the function, the square root of the absolute value of the square root of x plus 3 minus 7/4 plus x over 4, and we want to make that less than 0.1. Now using the absolute value, which is less than 0.1, we can then say that this is going to be in between negative 0.1, and we have the square root of x plus 3 minus 7/4 minus x over 4, and that's less than 0.1. Okay, so what we're going to do is we're going to then do something a little different here. We're going to subtract the negative square root of x plus 3 to all three sides here. And so what we end up getting is negative square root of x plus 3 minus 0.1, which is less than negative 7 over 4 minus x over 4. And then that's going to be less than negative square root of x plus 3 plus 0.1. Okay, so now what we're going to do is we're going to multiply everything by negative 1. So if we multiply everything by negative 1, that means it's going to flip those inequality signs. So we end up getting positive square root of x plus 3, and that's going to become plus 0.1. And then we're going to flip the inequality, and we get positive 7/4 plus x over 4. And again, we're going to flip the inequality, and this becomes positive square root of x plus 3, and that's minus 0.1. Okay, and so now what we're going to do is we're going to rewrite the inequality. And that means we're going to write this now over in this side, so we're going to have square root of x plus 3 minus 0.1, and that's going to be less than 7 over 4 plus x over 4, and then that's going to be less than the square root of x plus 3 plus 0.1. Okay, so now what we want to do is we want to then multiply every term by 4. So we can do that. So let's go ahead and do that. We're going to multiply everything by the LCD, which is 4. And if we multiply everything by 4, we're going to get the square root of x plus 3 minus, you write that again, it's going to be 4 times the square root of x plus 3 minus 0.4, which is less than 7 plus x, which is less than 4 times the square root of x plus 3, and that's plus 0.4. Okay, so now we're going to subtract 7 to both sides. So we have 4 times the square root of x plus 3, and that's minus 7.4, which is less than x, which is less than 4 times the square root of x plus 3, and minus 7 plus 4 is going to give us negative 6.6. Okay, so now what we're going to do is we're going to split this up into two different inequalities. So we have an inequality here and then another inequality here. So the first inequality we're going to have is 4 times the square root of x plus 3 minus 7.4, and that's less than x. And over here we have x, which is less than 4 times the square root of x plus 3 minus 6.6. Okay, so on the left-hand side, what we can do is we can add the 7.4. So we have 4 times the square root of x plus 3, and that's less than x plus 7.4. Okay, and now what we want to do is we're going to square both sides of the inequality to get rid of the radical sign. So we get 16 times x plus 3, and that's going to be less than x squared plus 14.8x plus 54.76. And if we distribute the 16, we get 16x plus 48, which is less than x squared plus 14.8x plus 54.76. And then if we subtract the 16x and subtract the 48, we get 0 here, and that's going to be less than, which is x squared. 16x, negative 16x plus 14.8x is minus 1.2x. And then negative 48 plus 54.76 is going to give us plus 6.76. Okay, so that means it's greater than 0, so this tells us that this is always going to be true. Okay, so now what we want to do is we're going to go ahead and solve on this side. So on this side here, we're going to subtract the 6.6 to both sides. So we have x minus 6, or x plus 6.6, and that's going to be less than 4 times the square root of x plus 3. And then we're going to square both sides. So we're going to get x squared plus 13.2x. And that's plus 43.56. And that's going to be less than, well, it's going to be 16x plus 48, which is what we got in the previous one. So now we're going to combine like terms, so we get x squared, and that's going to give us minus 2.8x. And then minus 4.4, which is less than 0. So now we're going to use the quadratic formula. So using the quadratic formula, we're going to let x equal negative b, which is negative 2.8, plus or minus negative 2.8 squared minus 4 times a times c, which is negative 4.4, all over 2 times 1. So we get positive 2.8 plus or minus the square root of negative 2.8 squared is 7.84. And then that's going to be plus 4 times 4.4, which is 17.6. That's all over 2. So we get x, which is equal to 2.8 plus or minus, this is the square root of 25.44, because 7.84 plus 17.6 is 25.44, and then we're going to divide that by 2. So what that means is that these two are going to be in the interval, and that interval is, we have 2.8 minus the square root of 25.44 over 2, which is less than x, which is less than 2.8 plus the square root of 25.44 divided by 2. And so therefore, we know that x is going to be in between negative 1.2 and 3.92 for the approximation. In this case here, for the approximation with the accuracy to within 0.1. And therefore we can see that x is going to be in between those two values. Okay, and before we complete this problem, I also want to show how you were able to answer this question by just using the graph as opposed to finding the interval here. So what we're going to do is we're going to go ahead and graph, so we can see here that the linearization function is 16x plus 48. So we're going to go ahead and graph that, 16x plus 48. So therefore that represents L. Okay, and we know that there were two quadratic functions where it said 16x plus 48 was greater than x squared plus 10x plus 25. So if we have x squared plus 10x plus 25. Okay, so you can see here that it's intersecting at 2 points here, right? Now, what are those 2 points? Well, I'm going to go ahead and copy that graph so you can see what those 2 points are. Okay, so I want you to notice that on this graph, okay, the interval, and we can see that the interval of what we're looking for is in between negative 2.7 and positive 8.7. And those are the values of x. So we could actually graph and determine what this interval is according to the value of x. Now, but we also want to take a look at the other one as well. So what did the other graph look like? So the other graph, the other quadratic function, so let's take a look at that. I'm going to go ahead and graph that one. So we had x squared, and that's plus 2x plus 33. Okay, so if you take a look at the linearization here, okay, we had 1, and then it crosses here. But recall that because it was always true, we didn't have to worry about that scenario. So therefore, we don't need an interval because it's going to always be true for every x. No matter what you put in for x, it's always going to be greater than 0. It's only true here between negative 2.7 and 8.7. Okay, and then likewise, let's take a look at this one over here. So if we come back here, we have the line of x. So the linearization would be x is what's in the middle here. And we know that this quadratic was greater than 0, so it was always going to be true here. So we're going to look at 4 times the square root of x plus 3 minus 6.6. So let's go ahead and put that. 4 times the square root of x plus 3, and that's going to be minus 6.6. Okay, so now we want to look at the interval for where it's going to be less than 0. Well, if we take a look here, there's the value of x there, and then there's 1 there. So let's go ahead and copy that. Okay, so let's take a look at the values for x here. We can see that x is going to be in between here is negative 1.12, which is negative 1.13 here. And then we have 3.92, and there's 3.93.